So the title of our presentation today is quantum mechanical treatment of multi-electron atom. By multi-electron atom we mean to say more than one atom having more than one electrons revolving around its nucleus. Myself, Dr. Nisar Ahmed. I will be teaching this course for next 4 months. So what does a 2-electron atom mean? A 2-electron atom is the simplest example of many or multi-electron atom. A nucleus with 2 electrons revolving around it is known as 2-electron atom. By default, when we talk about 2-electron atom, we think about this helium atom as 2-electron atom. Helium atom is a typical example of 2-electron atom which is neutral and naturally abundant, but with the advantage of new technologies we can ionize any atom to any degree. So you can have 2-electron atom of any atom. For example, you can ionize a uranium atom 90 times easily these days. So you will be having helium like uranium. Or you can ionize carbon atom 4 times. So only 2 electrons are revolving around its nucleus. So that will be 2-electron atom with carbon nucleus. Normally in general terminology is that you call them ions, but here we call them atom. That's the basic difference. I think this point is clear to you people. Now we will look at a simple 2-electron atom. Look at this diagram. There are 2 electrons revolving around the nucleus at relative distances r1 and r2 from the center of the nucleus. And we always take here nucleus as a point object. We don't look into the nucleus. So we take it as a point object, and Rij is the relative separation between the 2 electrons. This Rij plays a vital role in multi-electron atom because this Rij interconnects the relative coordinates of the 2 electron, that is r1 r2. You can see magnitude of Rij is equal to magnitude of r1 minus magnitude of r2. So as a result of this coupling of coordinates of the 2 electrons, the wave function of the 2 electrons become entangled, and because of this entanglement of wave function, so you cannot break down the wave function of a 2-electron atom into product of the individual electronic wave functions, that is psi r1 r2 cannot be written as psi r1 multiplied by psi r2, and that is the main problem we face when we deal with 2-electron system. So if we want to apply Schrodinger equation to 2-electron atom, what we have to do, we simply have to use this kinetic and potential energy. Here we are neglecting a lot of terms of 2-electron system. For example, we neglect the dimensions of the nucleus, we neglect the charge distribution within the nucleus. We consider the nucleus here as a point object of infinite mass, a point charge of infinite mass. So there would be some error. In fact, there is one main issue with the Schrodinger equation is that we don't take spin of the electron into consideration. We always reject the spin of electron as well as the nucleus. So the Schrodinger equation does not keep record of the spin. So let us start building the Schrodinger equation. There will be 5 terms in the Schrodinger equation. Kinetic energy of first electron, that is by first electron we mean to say the electron which is the relative separation of r1, distance r1 from the nucleus. Electrons are indistinguishable. There cannot be first electron and second electron. We cannot distinguish between that. In fact, these are quantum mechanical particles. entities. So classically you can have distinguishable systems, but here we cannot have that thing. So this is the Schrodinger equation if you look at it. I think this much is enough.